Good morning, students. This is the lecture for class 11, and today we are going to study the problems of solubility product. We have learned in the previous lecture that what is solubility product and what are its applications. And I have seen the work, many students have done their work really well in class 11. Um, Today I'll teach you how to solve the problems based on solubility product. Before I start, I must tell you that this topic, solubility product, its application, and its problems, is the most important topic from the sixth chapter for this year 2020. So I will just start up, and the first problem that I'm going to discuss with you about the solubility product is how can we calculate the solubility product if solubility is given to us. If you can read the problem, the solubility of solution at this temperature of magnesium hydroxide at this temperature is 0.00764 gram per decimeter cube. What is the solubility product of magnesium hydroxide? Now this example which I'm going to solve for you here basically is from your textbook, and in your textbook it is question number 17b. So I hope you will see that one. Again, in the yellow, solubility is given and solubility product is asked, which means Ksp is asked. So first thing first, we will write the reversible equation that shows the solubility of magnesium hydroxide. As you know, MgOH2 will basically will ionized into magnesium 2 plus ions and 2 hydroxy ions. So in this given data, we have the solubility of MgOH2, which is 0.00764. In order to find the ionic concentration, we will divide this solubility by the molecular weight or formula weight of the given salt. Now, you know that solubility product is the product of the ionic concentration, right? The quantity of ions, the active mass of ions, when they multiply, that's Ksp, right? So 0.00764 is solubility of the salt, not the ionic concentration. We can, however, find the ionic concentration from given solubility if we divide this solubility by the molar mass of the given salt. So 0.00764 divided by 58, which is the molecular weight or formula weight of magnesium hydroxide. And this is the answer. This answer is basically mole per dm cube. This is the X. And by X, I mean the ionic concentration. For Mg, it will be just X. And for OH, it will be 2X if you know why 2X. If you've been doing the problems of Kc, you would easily guess why 2X. So for magnesium plus ion, this is only one magnesium plus ion, so the X will be same for it. However, the 2OH, so this will be 2X. So to do 2X, you have this answer. Okay, now you know to find the Ksp. Finally, Ksp is the product of ionic concentration, and the way we write active masses, the Mg2 plus in the square brackets and the OH minus 1 in the square bracket and with the power 2, if you can see over there. If you can see over there, my dear friends, because here this only one Mg2 plus ion. Okay, so this is Mg plus 2 plus. There are two OH minus ion, so this is OH minus 1 power 2. And because this is one magnesium ion, the value of the ionic concentration for magnesium ion will be same as X. Because there are two OH ions, so it will be 2x. We just multiply this x with 2 and this is the answer. So if any problem, they give you solubility, you don't worry. Just divide the given solubility by the molar mass of that salt. And then look at the number of ions in from the balance equation. If this just one, let's suppose if it was NaCl, okay? So in the case of NaCl, it will be Na plus and Cl minus, which means that X will be Na, X will be Cl. There's no 2X required. For let's say AlCl3, a aluminum trichloride, there will be one aluminum and three chloride ion. So this 3X. So you know what I mean? Exactly. Any salt, don't worry. If the problem gives you solubility, divide that solubility by the molar mass of that salt. If I can take you back where I was. In this problem, it's magnesium hydroxide. In different problems, it would be different salts. But would you worry about it? Of course not. You would simply divide the given solubility by the molar mass immediately. The answer will be the ionic concentration X, and that would be X, or that would be 2X, that would be 3X, depending upon the number of ions in the salt. So MgOH2, see that? MgOH2. So you can see, my dear friend, I can again show you here that this is our salt in this problem. Okay, different problems will have different salt. Here MgOH2. So Mg is one ion and OH are two. So for Mg, this X will be the answer, and for OH, you just multiply by 2. So here we go. It's very easy to see. After division, we have X. The same X is the ionic concentration of magnesium ions, but just double that, that's ionic concentration of the OH minus ions. Very simple. And after that, so I repeat for you, I'll just take a pause here again. You have to see the kind of salt given in the problem. Suppose if it was NaCl, you will divide by the molar mass of NaCl. If it was aluminum chloride, which is AlCl3, divide by the molar mass of AlCl3. But the number of ion like AlCl3, so 3Cl, so it's just 3x. Once you find the x and 2x, what you do, you write the Ksp expression. How we write the Ksp expression? We put the ions from here, Mg2 plus is Mg2 plus. OH minus, OH minus. Difference is that since there is 2 OH, so power is 2. Now we will put the values. Where the Mg2 plus, simply X. 1.3, 10 power minus 4 mole per dm cube. Where there is 2X, we put the value of 2X. 2.6, 10 power minus 4 mole per dm cube, whole power 2. Now when you solve it, you have the answer. Interestingly, the answer will be mole cube, right? Because there's a square here. Okay, so the mole square into mole cube, you first square this value, then into this value. This way you can find the Ksp for this salt. I haven't solved it. This is the solution is for you. I hope you will find the solution by yourself. Easy. If you don't understand, please write to me in WhatsApp that I will repeat for you. Okay, this problem is in our textbook. It is on page number 191 and it is the problem number 17b. However, if you want to solve an extra problem, then in your textbook on page number 183, you have a similar problem. But it's a solved, yeah. But the salt there is AgCl. So if the salt is AgCl, you divide the given solubility by the mass of AgCl, and because it's AgCl, Ag and Cl, just the Ag, so XX is same. So this will be XX, and even there's no square. So it's an easier version of it. So please solve the 17b on page 191, and please solve as a problem the example on page number 183. All right, and check your unsolved paper. If there are other salts whose solubility is given, you can very easily calculate first the ionic concentration, which is the step 1. You divide the given solubility by the molar mass of their salt. Different salts have different molar masses, and then there will be X. So that will be X or 2X or 3X depending upon the number of ions present in the salt. You can write the equation like I have this here MgOH 2 and then Mg. Even if you don't write the equation and if you know it's AgCl, it will be X for Ag and X for Cl. If it is CaCl2, then X for Ca and 2X for Cl. If it's AlCl3, then X for aluminum and 3X for chlorine. And that 3 will also be the power in the formula of active masses. So you know what I mean? These two problems are very much important. Kindly solve them. Kindly don't copy them, but solve them and get ready for the examination for a problem as such. So this one type of problem where in solubility product, there are three types of problems. One type 1, when solubility is given, all right, and they ask you Ksp. This problem and examples on page 183, same. The type 2 is when solubility product is given and X is required, which means the ionic concentration, the solubility is reverse of this problem. Look at this problem. Ksp is given for potassium chromate, PbCrO4, Pb2 plus is 1 ion, CrO4 2 minus is 1 ion. This is XX. It's not CrO4, this 4 doesn't mean there are 4 ions. CrO4 is 1 ion. Okay, this is 1. This will be X. Now, what is the solubility of lead chromate when they give you the solubility product? Ksp is given, solubility is required, and at room temperature, of course, 25 degrees C is the room temperature. Now, in this problem, just a few things, but reverse. You write the equation first. PbCrO4, Pb2 plus, CrO4 2 minus. CrO4 is a complete radical. Now, what will be Ksp? It will be just the ionic concentration. Pb2 plus in square brackets, CrO4 2 minus in square brackets. So it's XX. Now, Ksp is given. So we write the Ksp, 2.8 10 power minus 13 and XX. Now, x squared. To find the value of x, square root on the right side. And this is the ionic concentration. This is the ionic concentration of each ions, Pb2 plus and CrO4 2 minus. To find solubility, in the last problem, we divide by molar mass. In this case, we multiply by molar mass. So, very simple. To find solubility product, molar mass into ionic concentration. All right. So, what is the ionic concentration? 5.29 10 power minus 7 into 323. And what is 323? The molar mass of PbCrO4. Okay. Different salts will have different I'm sorry, it's PCr4, it should be PbCrO4. This one, this problem is in our textbook. It is the 16b. So 16b and 17b are opposite to each other. In 17b, they give you solubility, ask Ksp. In 16b, they give Ksp and ask solubility. So if in first problem you divided by molar mass, okay, to find ionic product, here you will multiply it into the molar mass to get the solubility. So just it's the same thing, but it's an opposite. Okay, so I hope that you have understood. The answer is again left for you. When it is solved, it is gram per dm cube, the solubility of PbCrO4. So this problem and this problem are very simple, very easy, opposite. Solubility given, divide by molar mass. Divide by molar mass, that will be x or 2x, depending upon the salt. Multiply them by Ksp formula and you have the answer. This is just like on page 183, one example. And in this problem, what you do, you have the Ksp. So from Ksp, you find the x first. Now, xx or x2x or x2x square depend upon the salt. If you go to page 184 in your textbook, you will see on 184, there is a salt which is x2x. So x into 2x whole square. So this is a 4x cube. Divide by 4, then cube root of that value. For a square root, you have button in your calculator. Cube root also have button in the calculator, which is like a root and 3 on it. So just you can find cube root as well. In both problems, you find first the x, you multiply the molar mass. On the problem on page 184, which is solved problem, also there's a x cube a cube root, and then you just multiply the molar mass and you have the answer. So type 1 problem, solubility given, Ksp required. Type 2 problem, Ksp given, solubility is required. Two problems in textbook, two problems in examples. So you can solve them both and master the technique for yourself. And check the unsolved paper. Interestingly, these problems are so much at the end of the textbook that most people miss these problems. And obviously, they come in the examination as it is, just different values. So if you master them, you master everything. All right. Now type 1 done. Type 2. Now type 3. In type 3, they don't ask for either Ksp or solubility. Okay. They give Ksp, and they somehow give ionic concentration, and then you multiply the ionic concentration. If the answer is more than Ksp, you say super saturated solution. It will precipitate. If it is less than Ksp, what do you say? It is unsaturated solution. Okay, it won't precipitate. If it is equal to Ksp, you say what? It is saturated solution and it won't precipitate. So type 1 is about finding Ksp from solubilities. Type 2, finding solubilities from Ksp, and type 3 to determine whether a solution will precipitate or not. There we go. Let's try. Type 3 is a little bit complicated, but not that complicated if you try to focus, okay? So in this problem, excuse me, uh, will cadmium hydroxide precipitate? It means you have to decide whether the solution is super saturated or it is not. Ksp is given, 0.01 molar CaCl2. Now what is 0.01 molar? This is the concentration, okay? Concentration of the calcium and OH ions. So if you have 0.01 molar cadmium chloride, which means the cadmium ions are 0.01, which means about -2 mole per dm cube. Fine, you have cadmium ions. Now 0.01 molar cadmium chloride, it means the cadmium, this is not calcium, it's cadmium hydroxide. Sorry, I should change the value because it's a problem here. So this is cadmium. So the value from cadmium chloride gives you only cadmium. The given 0. If you see that, they give you 0.01 molar cadmium chloride. So 0.01 molar is the cadmium ion concentration in here. What about the OH ion concentration? To find the OH ion concentration, we use a formula. We all know that pH is for acids, POH is for bases, and their sum is 14. Okay, so if you have pH and you want to know POH, so then you do what? 14 minus pH. So this is 5, the answer. So 5 means, and we all know it will be 10 power minus 5, because pH or POH are the negative log of the H plus ion or OH minus ion concentration. So if POH is 5, how can you find the OH minus concentration? Find that, you get the antilog of 5, minus 5, which is 10 power minus 5. Simple and easy. If pH is 9, 14 minus 9 is 5, the ions are 10 power minus 5. If the pH was, let's say, 10, 4, 10 power minus 4, you can easily predict this one, okay? OH minus ion concentration. Now you just multiply this yellow and this yellow. Just multiply this guy and this guy. This is the cadmium ions concentration. This is the OH ion. If you multiply and the answer is more than this, you will say cadmium hydroxide will precipitate. Let's see. Okay, this is how it is. CdOH2 will make Cd2 plus and O2OH minus. Now put the values. 10 power minus 2 for Cd and 10 power minus 5 for OH, but there is a square from the law of mass action rule. Multiply them, the answer is 1 10 to the power minus 12. Now let's compare to the Ksp. Ksp is 2.5 10 to the power minus 14. And the ionic concentrations are this. Okay, I should write, I should rather not write this. I'm sorry. We should write here not Ksp, but we should write here this product of what? Ionic, sorry, concentrations. So product of ionic concentration is found like this. So we have to just replace product of ionic concentration and product of ionic concentration. It's not Ksp. Now at this moment, just compare. The product of ionic concentration here is 10 power minus 12. Remember, 10 power minus 12 is much bigger than minus 14. Keep in mind, okay? Minus 14 is smaller. So now you can see that the ionic concentrations are more than the Ksp. This is going to precipitate as the ionic concentrations are greater than Ksp. That's why solution is supersaturated and it shall precipitate. I have seen this question many times in the examination. As I mentioned, the KSP problems are at the very end of the book. So most students and teachers basically don't even reach at this place. These problems come almost same, just they change the value. So if the cadmium chloride is 0.01, so we have that cadmium ions concentration. If the pH is 9, we find the POH by subtracting, okay? We just find it by subtracting, basically. This was the first method, this was the second type of problems, and now this was the third. So if cadmium chloride ion, let's say if in a problem they give us 0.005 molar, so this will change here 0.005, and in the end we'll multiply with OH minus ions. If pH is 9, you just minus from 14, the answer is 5. OH ion will be 10 power minus 5. If pH is, let's say, 10, it will be 4. If pH is 11, 3, 10 power minus 3. So it's a similar roadmap, just follow the same over and over again. And if pH is 5, POH is 5, then OH minus ion at 10 power minus 5. Okay, multiply these ionic concentrations. And once you multiply the ionic concentration, keep in mind, salt should be seen. Cadmium 2 plus is 1 ion, then 2 OH minus, so OH power will be 2. Just to square that value there, multiply into this, the answer is this, and you can see very clearly the product of ionic concentration is much higher. 10 power minus 12 is much bigger than minus 14. Okay, don't look at the 2.5 and 1. Okay, look at the powers. So it means that solution is what? Solution is super saturated. And if a solution is super saturated, that means it is going to precipitate. Dear fellows, three types of problems. Finding Ksp from solubility, we have learned. Finding solubility from Ksp, finding solubility from Ksp, we have learned. And now determining whether a salt is going to precipitate or not. It is even easier. We multiply the ionic concentration and compare with the Ksp's value. For the ionic concentration, one ionic concentration is directly given, and the other is found by subtracting from 14 and pH and then powers and all simple. This is much easier to me, I guess. So this is this one problem which I just solved is in your textbook, and it is the problem number 17A. So 16B, 17B, now 17A. Kindly learn it, solve it, if it is, and do show it to me. If there's any problem, you can ask me. All right. And next problem, last problem, is basically almost the same. Whether should AgCl precipitate? It means they're asking if it is supersaturated or not. This time, look at the values. 1400 ml of zero point 0.1 NaCl, 1600 ml of 0.03 AgNO3. So what is the volume in total? 600, 400, 1000. One beaker, 1400 ml, 400 ml of NaCl. Other beaker, 600 ml of AgNO3, and they are mixed. So when they are mixed in one container, 400 of NaCl, 600 of AgNO3 makes what volume? 1000 ml. So 1000 ml is the volume of the mixture. But the mixture contains zero point 0.1. See, I made this blue and yellow. The yellow is for the chloride ions, correct? And the blue is for the Ag ions. So how can you find the ionic concentration? First we need ions, then we multiply them, and then we compare with the Ksp. So look at this. Volume of AgNO3 into molarity of AgNO3 divided by volume in total. It means that 300, it means that volume of AgNO3, 600 into 0.03 divided by 1000. Same for Cl ions, 400 into 0.1 divided by 1000. So 600, the volume of AgNO3 into 0.03 molarity of AgNO3 divided by volume total, which is 1000, and the answer is 0.018 moles. For Cl ions, same, but when there is 600, we add 400 because NaCl is 400. 400 into 0.1 divided by 1000. So you have this. Now just multiply them. The answer is 7.2 10 to the power minus 4. Now tell me what is the thing here. Ksp minus 10. Ionic product minus 4, which is more. Ionic product is a lot more than Ksp. Okay, minus 4 is bigger. This is going to precipitate for sure. Easy, easy peasy. If you want to do practice in our textbook, we have an example on page number 185, which is a similar problem as this one in which I have solved. So total we have done four problems basically, 3 types of problems from assignment and 3 from the book. So I want you to solve it and I want you to show it to me so that our solubility product section is complete. This will be our basically our last topic. No, we have one topic basically left, which we can do easily, like in tomorrow's lecture, and then our 6th chapter will be complete. Once we complete our 6th chapter with all problems and everything, we will be ready to take a test and we'll be ready to learn this one. And I will need your feedback that how do you like this chapter and how our work was. I hope that you are you are enjoying your work at home and work hard and share with me your work. Thank you so much. Goodbye for now. We will now meet tomorrow, same place, same time, and with the last topic of 6th chapter. All problems have been done from the 6th chapter already. Thank you so much. Goodbye.